Hello students, welcome to the model number 2, failure of materials. In this chapter we are going to discuss in this video two content. One is stress relaxation, another one is concept of formation of alloys. Okay, so let us discuss. In the previous class we discussed about the different mechanism of creep. Now we are going to discuss about the stress relaxation. Okay, what is mean by stress relaxation? Okay, so what happened in materials which are different uh, different materials which are have intended to function at a higher temperatures must be creep by the creep resistant. Okay, so some of the creep resistance material includes example we can say refractory metals containing elements at high temperatures like titanium and other etc material, or tungsten base alloys, or super alloys like cobalt and nickel. Okay, and by solid solution the alloying and addition of the depressed phases, and steel based alloys, or even though if you call it as thoria, that is also depressed nickel. Okay, this is all about the creep resistant material. So what happened whenever the stress relaxation is defined, it is observed that a decrease in the value of stress in solid material which are not allowed to elongate. Okay, not to allowed to elongate. For example, suppose if you fitted the bolt and nut assembly which is holds two or more parts together in tight contact for a long duration. So after a certain continuous usage of that, what happens, stress is going to be built in a bolt as well as nut, and it reduces after a long period of times, it results of a creep. Okay, so due to the continuous prolonged usage of that, so it develops creep. So in other words also what we can say, the stress initially the stress is the relaxed during the passage of time. So somehow it will going to be stress is going to be released, or we can develop the creep. Okay, so for example how we can say, even if you take consider a small specimen subject to a constant tensile load. Okay, say sigma 1 at an elevated temperature, so the total strain, that is a epsilon, is given by the equation of what it will becomes. So epsilon is equals to epsilon e plus epsilon p. So what we can say, epsilon e means the elastic strain, and epsilon p is the plastic strain. That is what we call the creep. So under this condition, the steady state creep is going to be allowed to tends to elongate. So but if the deformation is constrained, the total strain remains constant at any point of time. Okay, even since the total strain does not change with the respect time, so differentiate this epsilon, then we'll get the equation. So that time and it will be equals to 0. So this is about the stress relaxation. So this and also this creep test sometimes referred to as a stress relaxation test also, because it is used for the determining the amount of deformation material and experiences that over time while under the continuous tensile or compressive load or at a constant temperature. So these are all about the the stress relaxation. So this will be required for any of the assembly parts, like with the help of nut and bolts. So there is after long usage of these things develop the creep. So for that, to know the what is the stress relaxation, so how much stress is developed and what will be the strain, everything will be find out by conducting this stress relaxation test. Okay, next we'll discuss about the concept of alloys. So in this concept of formation of alloys, uh, we must understand how the alloys are going to be formed for different materials. Okay, suppose if you take pure material that possesses the unfavorable properties, like and also it is used for the some specific applications. In order to enhance these properties of that metals are combined with the other metals or non-metals, so resulting that the metal is going to be called alloy. Okay, so this alloy can be defined as a homogeneous mixture of two or more metals, or mixture of metals and non-metals, usually prepared by melting them together and solidifying the mixture. Okay, so this salt and for example, for example, alloys include steel. Suppose if I say steel means it is constituted of the iron plus carbon. Okay, iron and carbon. This is the content which there in the steel. Suppose if I say brass means, example, it will be copper plus some zinc. Okay, suppose if I say bronze means copper plus tin. So these kind of things are going to be added to strengthen or material, and also it is useful for that particular application. Even though if I say duraluminum means what, aluminum plus copper. Okay, duraluminum means copper and aluminum, like that. Such combination they will take and forms the alloy. Okay, so different types of alloys. So as I said, the base metal are going to be added with some other tops, and these alloys, as I already told that, so you can have, there are two or main types of alloys, and these are called as substitution alloys and also interferential alloys. So okay, these atoms are generally metal and are literally replaced by the atoms that have the roughly as same size from another material. As we discussed, for brass, an example to take for a substitution alloy of copper and zinc. So that will be matches with their atomic structure, and it will be form an alloy. So we can discuss what are types of alloy, you may ask. So when it is combination of two or more metals, or mixture of metals or non-metal, is consequently there as what we call it as completely miscible in the liquid state. Okay, and its combination is capable of forming an alloy. Okay, this alloy when cooled or solidified and can crystallize into another three types of alloys. So first one is a solid solution of metal elements. Second one is mixture eutectic mixture, and third one is intermetallic compounds. So these are all the different types of alloys. So let us discuss one by one. So what will be the solid solution of metal elements? So solid solution of metal elements is formed if the combination of metals retain their components, which is usually consequently their solubility in even their transformation from liquid state to solid state. Such a phase we call as single phase, or we call as solid solution of metal elements. Okay, this crystal structure is the same everywhere in the solidified alloy. Their transformation from liquid to solid state. Okay, and for the next type is eutectic mixture. So eutectic mixture means it is a mixture of metallic phase, that is a two or more solutions. Okay, two or more solutions. So eutectic mixture or alloy defined as a mixture of two or more components, which is usually do not increase to form a new chemical compound, but what happened, which at certain ratio inhibit and crystallizing the process of one and another. So it is resulting that the system having two lower melting points than the either of the components. So a eutectic system forms only when there is a what we call specific ratio between the components. So the combination of this tin and lead is used in soldering in a best example for electric rollers. Okay, so while doing a soldering, that is tin and lead are going to be used for the soldering process. So okay, that is an best example for your electric alloy. Okay, next one is intermetallic compounds with defined stoichiometry and crystal structure. What we can stoichiometry means what, perfect ratio of that mixture, that is what chemically perfect mixture, that is what we call as stoichiometry, and the crystal structure. So this will be composed a definite or fixed proportions of two or more elements or metals, rather than the continuously variable properties as in the case of solid solutions. Okay, so this crystal structure and the properties in metallic compounds often vary from those of their constituents. Like example, that is uh, copper and lead. Okay, that is in scientific we call it aroma and lead, Pb, Au and Pb, or aluminum and magnesium and lead, magnesium and nickel system. These are all the intermetallic compounds. Okay, so this is about the different concept of formation of alloy and having different types of alloys. So I hope you understood this concept. So some other further topics we'll discuss in the next video. Thank you.